Hello, so let's start the top k frequent elements, one of the most important patterns. So like we basically need elements with highest frequency and that up to k elements. So first of all we will discuss the brute force approach, and what we will do in brute force, like we can simply see like we have to count the frequency of the occurrences of the element, count the occurrences. Then we can do like, since it is a brute force, we can simply store it in a 2D vector, but we need to ensure that first of all frequency is stored and then the key value instead of key and frequency. So we need to ensure that, and after that what we can do, like simply sort the vector and then get the top k highest frequent elements. So now let's start the implementation part. So first of all we are gonna declare the map with integer and integer key value pair, and above that we need to declare a variable and which has the num size. Now we need to store the frequency of the element, like we need to count the occurrences. It is like a common part which will be done in both brute as well as the optimal solution, like I plus plus. So here we need to count the occurrences of the nums elements, like mpp nums of I plus plus. You can basically do it using an enhanced for loop, like for char c. Sorry, here not char, here integer will be there. Now we will basically take a 2D vector and store it in vector of vector, like integer vec, but we need to ensure like we are stored in frequency and key format. So like we are gonna use an iterator to iterate over the map. For auto it mpp vec dot pushback, first of all frequency, then the key part it dot second, then it dot first. So this part has been done. Now we need to sort the array. This is what we will prevent in optimal solutions because it takes an logarithmic of an complexity. So like sort begin vec and vec, and what it will do, like sort the vector in like increasing order, and but we want, yeah, we can solve it in increasing order here and then fetch the last and minus k elements, but it will be a like little bit more complex. So basically we can use a comparator function which will sort in like decreasing order. So sorting is also done. Now we will like create an answer vector, 1D answer vector, where we're gonna store the answer with yeah, answer will be fine. So for int I equal to 0, I less than k, since we need to fetch the top k elements, answer of this needs to be uncommented, vector answer dot pushback vec. Basically our answer, sorry, basically our element is like in 1th position, like in the 0th position we have the frequency, vector of I 1. Now let's return the answer. I hope it works fine. What's there? Sort begin greater. Sorry, here int will not be there. I was basically remembering the pair approach. For int where we need to declare the variable. Yeah, so we can say it's working fine. We will not submit it since it is a brute force solution. So like how we can proceed it to optimal. Like here the time complexity is for this is big O, logarithm, sorry, big O of n, since we are traversing the whole array. And here it is like we are pushing. So basically for pushing in a map, it basically takes logarithmic of 1, means we can say like big O of 1 solution. So that doesn't count, but here we are doing the sorting which will take logarithmic and log n, which n is basically standing here for the vector size. But what here space is taking, we are big of n. Here we are also taking a 2D vector. So basically in the optimal we need to remove this sort part. So for that we are gonna use the max heap, we can say, or we can use min heap both, but the implementation will be slight different. So let me solve it using min heap part. Like for that we don't need an answer vector, like remove it. Sorting is also not needed. Like element will be stored, like we need the frequency, but instead of the 2D vector we have used, they will use a parity queue. But for min heap we need to declare a like this slightly complex header, we can say priority, since we need to store a pair. So pair int comma int, pair int comma vector pair int comma int pair int, then greater pair int comma int. So 1 2 3, I hope the syntax is correct. PQ. So now we can like keep a count, like if you know what min heap, in like when we have used max heap we need to have push all the elements in the max heap. But in min heap what we can do, like we can restrict it to like priority queue to the only store k elements. If it goes or if it extends the size, we can simply pop the elements. So like after this we can basically iterate over the map for auto it mpp. What we can do, like in parity queue we can push as in the same order like we have done, like first the frequency and then the key part, like it dot second and it dot first. Since we know priority in min heap what is done, like smaller element is at the top and higher frequency is like lower part. So we have done this and we are like gonna restrict, or we can implement a condition like if pq byte size exceeds the k value, we are simply gonna pop it. So we are basically maintaining a window pq dot pop window of size k, and at last we will simply fill the answer vector, which will be a which where we will store the frequency. Like it will be a 1D answer vector int answer, like for int, sorry, we are gonna traverse over the priority queue. So while pq is not empty, we are gonna keep checking it. While not pq dot empty answer dot pushback, we can do answer dot pushback pq dot top. Top is a function in priority queue for accessing the top elements. Pq dot top dot second. I hope it runs correctly. Return answer. Sorry, here we need to ensure we do pq dot pop, otherwise it will give tla. So yeah, let's submit this. Yeah, it's working correct, fine. So let me explain you the time and space complexity. Here we are basically like this. Here we are storing the occurrences of characters in map, so it will be like big of one, sorry, big of n. And here we are using a priority queue. So like here, for pushing in priority queue, we take like we have u elements, or we can say for each push it takes logarithmic of k. And here we are like doing the whole, like the number of occurrences in map, like it is k times. So basically here total k occurrences, so like for each it takes logarithmic of say, so total it will take k log k, or we can simply use another variable u log u. So each push and pop takes k log k, but sorry, log k. So overall we can say like k log k, and for overall k elements we can say k log k. And here pq, it will basically, if we have k elements in the priority queue, so it will also take like big of k. So overall it will take time complexity of big of n plus k log k, or we can say if we are storing the n whole elements, consider that n only, so it will be an n log n. So overall n n log n plus k, we can, let me take it like n, because we're considering worst case solution, like we have to push everything in the priority queue. So like n log k and of k. So overall time complexity will be big of n. Talking about the space complexity, here we are using the answer. It will not be considered as in space. You have to explicitly mention it, like we have to use this, since that part that is in answer requirement. So basically here we are using a map as well as a priority queue. So like big of n is overall the space complexity we can consider. So this was my top elements solution. So thank you for watching it.